So in the last video in example number 4, we spent a little bit of time simplifying the difference quotient, and we ended up with 2x plus h plus 2 as the difference quotient. So at this point, what we're going to do is use that result and evaluate the answers in example number 5. It says, use the result of the last example to calculate the slope of the secant line, meaning the average rate of change, for the same function f of x equal to x squared plus 2x at x equal to 2 for h equal to 0.1. So instead of doing f of x2 minus f of x1 divided by x2 minus x1, we have to use the difference quotient that we just found. So we know that the difference quotient is 2x plus h plus 2. So all we have to do now is plug in the numbers into where they belong. So what is x, what is h, and let's see. In this problem, the x is supposed to be the number 2, so that's going to replace the value of x. And the h in this case is supposed to be 0.1, so let's color that in blue. That's the h, and that's what's supposed to go right there. So 0.1 and 2 and 4, so that's going to be 6.1 at the end. So that was pretty fast. That's going to beat any calculation where we do f of x2 minus f of x1 over x2 minus x1. By the way, we can do that if you want. We can do f of x2. In this case, x2 will be 2 plus the 0.1, so that's 2.1, minus f of 2, all divided by 2.1 minus 2. That would be the old way of doing things. And now what you have to do is calculate the numerator and the denominator. So 2.1 has to be plugged into that, then 2 has to be plugged into that, and then we have to calculate everything. So we can use a calculator to do these things, not a problem. And actually, when you plug in the numbers, you will find out that the answer is going to be 0.61 divided by 0.1, which is ultimately 6.1. So it again matches what we did previously. However, I feel like the previous way of doing things using difference quotient is a little bit faster. It doesn't even need a calculator to estimate the answer. So that's why we like the difference quotient method. So at this point, we're not going to be using that old technique anymore. We're just going to do the rest of the problem using the new technique. So for instance, in part B, or part 2 of the problem, it says h is 0.01, but x is still the number 2 from the start of the problem. So we know the difference quotient is 2x plus h plus 2, and at this point, what we're going to do is plug in 2 for the x, and h is 0.01 this time, and evaluate the solution. So again, the h is the same, and x is 2. So that's 4 plus 0.01 plus 2, which is ultimately 6.001. And that's it. And we can repeat the process again a third time for 0.001. And as you can see, the answer is going to be 6.001. I think I had a typo in the first one earlier, so make sure you take away one of the zeros that were there. I think I accidentally added an extra 0. However, the last one has 6 double zeros and then a 1. And as you can see, once you have the difference quotient, it's super straightforward to calculate the difference quotient and calculate the slope of the secant line. So I just want to kind of again repeat what we're doing with these problems. So if you imagine that we have an xy plane, and if you imagine graphing the graph of x squared plus 2x, it will kind of look like this maybe. You'll notice that what we're doing right now is this. If you stand at the number 2 and you put a gap of 0.1, you get 2.01. The line connecting these two dots, that line has a slope of 6.1. That's what this work basically shows us. And the smaller the gap is, the closer the numbers are to each other. Ultimately, if the gap is super tiny, almost 0, there's no more secant line. It becomes called a tangent line. That's where we're going with all of this discussion ultimately.